Alrighty, so for this week's lab or interactive advanced concept presentation, we are going to be looking at the table 9.2 in the textbook, and I'm going to be using balloons to demonstrate how the different electron domains work. So we will go through the entire table, and I'll use the balloons just to show exactly how that does work. So the first thing we have is going to be our trigonal planar. So for this, it's going to be relatively simple. It's pretty much just going to look like this right here. Sorry, let me make sure you can see it. Just like this. It's going to be pretty much a flat one. There's not anything butting up from the top or anything from the bottom or off to the side. It will just be like this. There would be one number of lone pairs in this, and it would be a bent molecular geometry. An example for something that would be trigonal planar would be SO2, for example. Right after that, we will jump to our tetrahedral shape. So for this one, I'm going to still use this same base right here, but we will actually then take another balloon, and it will kind of go off like this. So if this is the bottom right here, you'll see this going off like this, and this is going to be what we call tetrahedral shape. An example of this would be like NH3. So you have your 3 hydrogens and your 1 nitrogen, and the molecular geometry shape that this will make would be trigonal planar. Like before we had the bent one, now we've got trigonal planar. And it would look something like this. After that, we are going to go to trigonal bipyramidal. So for this one, it's going to be like this, right here. So it's kind of going to be the same concept as before. We still have those 3 green base ones right in the middle, but this one will have a atom off the top and right off the bottom. And so for this, an example would be like SF4, and it's going to be like a seesaw-shaped molecular geometry for this to be formed. Notice how we always do have these first original 3 green ones that I'm using here just to show that they were the original ones. For a lot of them we will see that, and then it'll just be other ones budding off of it. Not always will it be there, but for the most part it will be. Alrighty. Then we do have an octahedral shape as well. Let me undo these real quick. There we go. So for this one, we're going to still have this green base pair, but I'm going to use a blue one right here to kind of wiggle it in. And instead of it being just a 3 base pair, it's going to be 4 like this. And then I'm going to bring these 2 pink ones back, and they're going to bud off the top and the bottom. So let me get those in there. So it'll look like this. So this is kind of hard to show, but we still have our 3 green right here. There's a blue in the back. It's hard to see, but I'll just slowly spin it as I talk. And so for this, it's going to be a square planar molecular geometry shape. An example of this would be you could have like a BRF5 as an example. So you do have these 4 right in the middle, 1 budding off the top, 1 budding off the bottom. This shape could have either 1 or 2 number of lone pairs, depending on the different elements that make it up. A lot of these will have either 1 or 2 lone pairs, so we can see that the very first one I went over, which was just let me try and get this undone. So remember the 3 green I had in the beginning, now it's just, they're all coming undone. So the 3 green that I talked about in the very beginning, the trigonal planar, this one would actually have a total of 3 electron domains, like we talked about, and only 1 lone pair. Then when we had the tetrahedral, which had one coming off this would have a total of 4 electron domains, and it could have either 1 or 2 number of lone pairs, depending on which one the different elements that make it up. After that, remember we had the trigonal bipyramidal one, and that was one where it had the 3, and then we had the 2 coming off the middle like this. That could either have 1 or 2 number of lone pairs as well, but it's going to actually have 5 electron domains for that. And then the last one we talked about was that, to go back to the trigonal bipyramidal, that could have 1, 2, or 3 number of lone pairs, not just 1 and 2. It could have from 1 all the way up to 3, depending on what is made up of it. Then going back to our octahedral shape, which I don't think I'm going to be able to get back really because they're all coming undone on me. Try. So remember we had 4, and it looks like this. So for this octahedral shape, it will have a total of, it could have 1 or 2 number of lone pairs, and for the number of electron domains, it's actually going to have 6. Remember, this would be a square planar molecular geometry shape. And an example again would be like BRF5 for this. So that is the entire table that was in our textbook. So that hopefully gives a better idea. It was a lot easier to see these and make sense of it using the balloons, because it's something 3D that you can kind of move around and see how the angles and everything come about. So yeah, it worked out pretty well, I think, minus the balloons coming undone a little bit. But yeah.